Hi, and welcome to another BREWHA video. In this video, we are going to demonstrate how to assemble the BREWHA BIAC brewing system. The BREWHA BIAC is the simplest way to brew the best beer. It is simplest to set up, it is simplest to operate, and it is simplest to clean, and it takes up the smallest footprint of any commercial system, while still providing full control over the brewing process so that you can make the best tasting beer exactly how you want it. All of this is achieved by reducing the brew house, what in a traditional brewery is a large platform with multiple fixed vessels and lots of piping and pumps, to just one vessel, the mash colander. One mash colander can be used in as many different BREWHA fermenters as a customer wants to meet the production needs of their brewery, be it 1, 2, 4, 6, or 10 fermenters, you name it. In this video, we will be setting up the BIAC system, which includes one fermenter. So for breweries with multiple BREWHA fermenters, the steps would be exactly the same, but you would just be repeating the fermenter assembly steps for each additional fermenter that you purchase. In this video, we are assembling the 1.5 barrel BIAC. However, the installation steps are almost identical for all of the different sizes. We will get to the equipment in a minute, but as a bit of background to the building itself, today, as you can see, we are setting up here in a warehouse, the BREWHA warehouse in Victoria, which is basically a big box. The BREWHA system is quite flexible in what it can fit into. Any building from a garage to a retail space and everything in between can work just fine. Here, like most buildings, we had power available at the panel, which is where it comes into the building, and an electrician ran a cable over from that and tied it into our controller. Since we're moving our tanks around on casters, if we were doing floor work, we would have put a drain or a trench along the back wall under the controller, not in the middle of the room because of the casters. But for the time being, we just use a mop to clean up. It is possible with the BREWHA system to have your wastewater volumes very close to zero, which is another major benefit of the BREWHA system, but most municipalities will want some kind of solid waste interceptor to minimize solids going down the drain. Your local architect or someone from municipal wastewater department will be able to confirm that for you. For taking care of steam from the boil, you can see we have a fan that can vent out of the building, and as another option if you can't vent outside, we have shown how we have installed the wall-mounted steam condenser. Cold water is ran through the jacket and condenses the steam as it passes down through the tubes. The only other utility-related item we installed is the reverse osmosis water purifier. If your region has good water, just filtering might be fine, but an RO purifier removes close to 100% of impurities. We talk a bit more about water in our brewing video on the website, and you can see the link to it here. So that covers the space, power, plumbing, wastewater and supply water, and venting for your brewery. More details about those requirements can be found on the BREWHA website, or feel free to reach out to us with any questions. Now to installing the BREWHA equipment. Assembly of the BREWHA BIAC is relatively intuitive and straightforward. You can be ready to brew in as little as a few hours, or for the commercial systems, maybe a couple of days. A brewer may want to substitute or alter a few parts, which is entirely acceptable, but this video explains how to assemble it in a typical manner. The BIAC photos in the manual are of the small size, and here in the video we're showing the 1.5 barrel system. The different sizes are almost identical for almost all aspects of the install, and special note will be made where they differ. Section 1 on packaging. The BIAC will arrive in 2 wooden crates. The fermenter, the 3-in-1 fermenter with the homebrew systems, and the 4-in-1 fermenter with the microbrewery systems, in one crate, and the mash colander in the other. Remove the screws and open up the crate. The fittings and accessories are packaged inside bags inside the vessels or in separate boxes. Before emptying the fittings out of the bags, look at the packing list inside the bag, as it may help you identify where the fittings from that bag should be installed. Section 2, the hoist. The small system doesn't require a hoist, but it can be used. A hoist is recommended for the medium and the large systems, and an expensive manual or electric ones can be purchased from local hardware stores and securely attached to floor joists or trusses. For the larger systems, install a gantry, which is an I-beam with legs, or the I-beam be connected to a structural beam, and mount the trolley and the hoist on the beam. Especially with the 7-barrel system, which requires a 4,000-pound I-beam, this is a 2 or more person job, and a forklift or a suitable lift should be used to position the equipment while it is being secured. Once the gantry and hoist are installed, the lift beam, or the lifting cable for the small, medium, and large BIACs, which is included with the complete accessory package, can be used to help remove the vessels from the crates. The larger vessels have lift lugs on the lid for this purpose. Ensure your hoist or your lifting mechanism is securely installed according to the manufacturer's instruction, and at no time operate underneath the vessel in a way that could cause bodily harm if the hoist fails. At this point, the Colander tipping cable, which comes with a barrel and a half to the 7-barrel systems, that will be used to dump the mash can be installed. It comes with the upper end already finished with an hourglass sleeve and a thimble, and an extra thimble, quick link, and cable clamp are supplied for the unfinished end. Connect the finished end around the trolley bar or the neck connecting the hoist, and adjust the cable to the length that you need so that when the colander is tipped, the bottom will be above your grain disposal receptacle. This way the spent grain can be easily unloaded. Then cut the cable and securely fasten the cable clamps once the thimble is in place. Section 3. Casters. The fermenter is shipped without the casters installed to prevent damage in transit. To install the casters for the small fermenters, first lock the wheel, which will allow the caster bolt to be screwed in manually. The casters on the barrel and a half to 7-barrel models attach with 4 M8 bolts, and there are 2 swivel casters and 2 fixed casters for each fermenter. The fixed caster should be installed on the side opposite of the fermenter push bar. The bolt should be installed through the caster plate and the fermenter leg plate with the nut side up so that the bolt does not impede movement of the swivel caster. Only use the fermenters on a flat, smooth surface and use wheel chocks to prevent rolling. To minimize the risk of accidental tipping, fermenters should not be moved when full, or if moved with extreme care. Inspect the bolts frequently and replace when worn. Section 4. The ports on the cone and the cylinder of the tank. Attach the first of the 4 sanitary valves, 5 with the barrel and a half to 7-barrel systems, to the bottom port of the fermenter by placing a gasket between the vessel and the valve and attaching a clamp. Use an 1.5-inch butterfly or a large ball valve, the 1 3/8 full port valve, here with the small, the medium, and the large BIACs, or the 2-inch butterfly with the larger barrel and a half to 7 tanks. The valve can be installed in either direction and it won't affect performance. However, with the dump valve on the small fermenter, the handle may need to be turned up to fully open the valve. One can attach a hose barb or a reducer to the outer side of the valves to connect a hose. Generally, a large reducer will go on the bottom port to assist in draining of trub or yeast cake from the fermenter. During fermentation, the brewer can dump yeast trub out the bottom port when fermentation is ending, normally about 4 to 5 days with ales, to prevent the yeast cake from getting too hard. And be sure to rinse the port thoroughly with water and sanitizer after every use so that microbial growth doesn't occur. A bottle filled with Star San sanitizer is ideal to have around your brewery. There are 2 sizes, the 1.5 and 2, or 1.5 and 3 of tri-clamp ferrule ports on the cone portion of the fermenter. The 2-inch sanitary ports are on the barrel and a half to 5 systems, and the 3-inch are on the 7-barrel only, which are for heating elements. There's 1 each on the small, the medium, and the large fermenters, 2 on the barrel and a half, 4 on the 3, 6 on the 5, and 5 3-phase 3-inch ferrules on the 7-barrel 4-in-1 fermenters. The uppermost 1.5-inch port on the side of the cone is for temperature sensor. The middle 1.5-inch port on the side of the cone is for a racking or a transfer valve. Since it sits above the level that trub and yeast normally settle during fermentation, it can be used to transfer and rack beer to the kegs. Other ports can be used as well for racking if desired. A racking arm can be inserted here before the racking valve. When using such a fitting, a Teflon gasket will rotate more easily than a silicone one, but it's harder to seal. The lower 1.5-inch port on the cone that only opens into the jacket, it doesn't open into the fermenter, is for chilling water to enter the jacket. The microbrewery 3 to 7-barrel models also have a 4th 1.5-inch port on the cone, just above the bottom of the cone, to which a valve can be attached for connecting a serving or a racking hose once yeast is removed, as well as a port on the lower side of the cylindrical portion of the vessel to which sampling valve or a sight glass can be attached. If any valve is not used, a simple cap can be used to close it off. Section 5. Water jacket. If using tap water for temperature regulation, attach the temperature control valve, the TCV, to the 1.5" port on the side of the cone that opens only into the jacket of the fermenter. Or it might be easier to first attach a valve to the jacket port and then the TCV, since the TCV can then be removed without emptying the jacket. This might be the case when switching from tap water, which is used after cooling the boil, to chiller water, which is used during fermentation. Use only clean water with the TCV at temperatures between 2 and 40 Celsius or 36 and 104 Fahrenheit. The TCV is used to shut off chilling tap water going into the jacket to cool the wort after boil and during fermentation if people are using tap water. So it doesn't need to be installed until after the boil is completed. Especially with the 120 volt small BIAC, it is best to leave the jacket empty during boil to reduce heat loss. The power cord on the TCV should be plugged into the cooling or the blue snowflake receptacle on the electronic temperature controller, the ETC, and you can see the programming and operating the BREWHA electronic temperature controller section of the website for more information on how to set that up. Or it could be plugged into the chiller cord on the touchscreen controller. If using warm water to warm the fermenter, and don't use over 40 Celsius or 104 Fahrenheit warm water, there will be overshoot. Then connect the temperature control valve or the TCV to the heating or the red flame receptacle on the ETC. The water pressure regulator should be installed either before or after the TCV to ensure that water pressure does not exceed the design limit of the jacket. The water pressure regulator should be installed with the arrow, which is etched on the back, pointing in the direction of water flow. During fermentation, if using the chiller to maintain fermentation temperature, the TCV should be removed and the chiller pump or the main chiller power plugged into the ETC instead of the TCV, and the chiller pump hose connected to the jacket inlet and the jacket exit hose returning to the chiller water reservoir. Ensure that the return hose is submerged and secured so it doesn't move or come out of the chiller. When the fermenter needs chilling, the ETC will power the chiller pump or the chiller itself instead of the TCV to let cool water circulate through the jacket and back to the chiller. The chiller cart is installed according to instructions which are included inside the cart box, and the 3/8 inch hose barb fittings and clamp to connect the hoses are installed by removing the shark bite connectors. If you are using tap water in the jacket for chilling, connect a hose to the upper jacket port on the side of the tank and run it to a drain. It is strongly recommended to never close or impede flow out of the fermenter jacket in any way, or pressure will build up, and to attach a high-quality, high-temperature, kink-resistant hose with a larger diameter than the input hose to the jacket exit port. This ensures that the backup pressure does not build up in the jacket and potentially damage the vessel. Section 6, heaters. Install the heating element and gasket on the larger 2-inch ports on the side of the cone, the 3-inch for the 7-barrel system. Install the element with a slot on the outer cap of the guard facing down, so it will drain if there is an internal leak. Section 7, water chiller. For closed-loop chillant circulation, for example, with a BREWHA chiller during fermentation, connect your chiller return hose to the jacket exit port and run it back into the chiller water reservoir. The return hose should be fully immersed and secured in the water bath, or air will enter the jacket through the hose and the jacket will siphon empty, possibly flooding the chiller and your floor. All flow out of the jacket port should be unimpeded, i.e. no valve, in order to prevent any pressure buildup. The jacket is designed to withstand no more than 5 psi of pressure, or 7 psi in the 4-in-1 tanks. Especially with tap water, the water pressure regulator should be installed on the water line going into the jacket. The regulator has an arrow etched on the side showing the direction of flow. Install it with the arrow pointing toward the fermenter jacket. Sometimes customers miss the arrow on the side of the regulator, so they install it backwards and the water doesn't flow through the regulator properly. The water pressure regulator is designed to not show any read on the gauge until back pressure causes it to rise. So sometimes customers will run water through it and say it's not working because the pressure doesn't read. It doesn't read until back pressure starts the gauge to go up. Pressure should be kept on the 3-in-1 fermenters below 5 psi and on the 4-in-1 fermenters below 7 psi. More can be learned about safety by referring to the safety section in the manual or by using the search word safety in the search bar on the BREWHA website. Section 8, lid and lid ports. Attach the pressure and vacuum safety valve to one of the 1.5-inch lid ports. Always keep this valve installed on the fermenter lid and test it regularly to ensure it is operating as designed. The 1.5 to 7 barrel models also have a large 6-inch center port for the CIP assembly. On the small to large size systems, the CIP is added through one of the 1.5-inch ferrules on the lid. The 6-inch on the 1.5 to the 7 barrel systems are also used for adding hops or installing a distillation column if you're going to be distilling. Install the 6-inch gasket, a cap, and a clamp to that port. If using carbon dioxide to rack beer to kegs, a valve or the stainless side blow-off assembly can be attached to a port on the lid to seal it. Then, using the fermenter gas in post and a regulator, maintain 1 to 2 psi or up to 15 psi or 14.9 psi in the 4-in-1 fermenters. Use that much gas when racking your beer. It is safest to always have the pressure relief valve connected directly to the vessel, not to a valve, so put the valve only on the second lid port. Ensure the valve stays open during fermentation to avoid any buildup in pressure in the vessel, which is designed to hold less than 3 psi in the 3-in-1 tanks and 14.9 psi in the 4-in-1 tanks. If there's any risk of someone accidentally closing the valve during fermentation, remove the handle once it is in open position just by taking the nut off the handle, and the handle can pop off. If carbonating in the 4-in-1 fermenters, install the stainless side blow-off assembly, or a T can be used to add a pressure gauge. This allows you to confirm how much pressure is inside the tank. To ensure a tight seal, the 4-in-1 fermenter lid clamp should be tightened in a star pattern, first by hand, gradually tightening to ensure that the lid sits evenly, then by using a tool. The 1500 to 5500 watt element wrench, which comes in the extras kit, can be used to good effect here. Regularly apply food-grade anti-seize compound to the bolt threads to ensure that they don't gall or seize. And if not using carbon dioxide to carbonate or rack, the hose barb can be attached directly to the port, or if using carbon dioxide, attach it to the valve. A blow-off tube, which is a section of 1/2-inch tube, is fine, should be attached to the hose barb and the other end placed in a bucket with a bit of star sand and water to allow the gas produced during fermentation to escape. For the blow-off hose, the mash hose can be used, but if you're going to be using the mash hose, make sure that you sanitize it thoroughly, or microbes that are in the mash hose might get back into your fermenting wort and cause an infection. It can be sanitized by just placing it in a pot of boiling water for about 5 minutes. It's probably the easiest way to do it. Chemicals can be used too if required. And figure 22 in the manual shows the end of the hose in a glass on the fermenter. But where practical, it is recommended to use a longer hose and place it in a bucket or glass on the floor so that if a small vacuum is created during fermentation, as water cools or the beer cools in the fermenter, it contracts, which will create a vacuum in the top of the fermenter. That vacuum then is going to suck water back up into the fermenter. So having it further from the top, that height difference prevents it from being sucked back into the fermenter. When crash cooling or otherwise cooling more than a degree or two, do the same thing. Be sure to remove the hose from the water or add 1 to 2 psi of CO2 to the top of the fermenter to counteract this vacuum that's being formed and prevent the water from being sucked back into the tank. Section 9, the ETC. Connect the temperature sensor to the ETC or to the touchscreen controller with the sensor cable by aligning the slot on the connector and pushing it on. When attaching, hold the cable connector collar and turn in a clockwise direction while very gently pushing in until the ridge and the groove align. Failure to align the cable and the controller sensor will likely result in damage to the connector. One of the pins might break, and of course then it's not going to operate correctly. The cable can be removed just by pulling down on the collar and pulling them apart. Never pull on the cable itself, as this can damage the connector, and check the cord grip on the connector frequently to ensure that it is gripping the cable securely. The ETC can be placed on the fermenter or hung from a wall or a vessel. There's a couple of holes on the back of the ETC where screw heads can be put into the wall, and you can hang the fermenter from that. See more ETC installation instructions under the Programming and Operating the BREWHA Electronic Temperature Controller in the Installation section of the manual, or you can search for ETC on the BREWHA website. Section 10, Water Level Ruler. To determine volume when filling the fermenter, hang the stainless water level ruler over the side of the fermenter when mashing and boiling. Remove the ruler before sealing the fermenter lid, of course, or it's not going to seal properly during fermentation. Section 11, Pump. If using a March 815 pump assembly, and the 815 pump comes with the small, the medium, and the large systems, and the March 7S comes with the barrel and a half of the 7-barrel systems. But if using the March 815, you wrap the pump, the NPT male threads, with Teflon plumber's tape and attach the tri-clamp fitting. Some food-grade Teflon paste can be applied to the thread prior to the tape if it is difficult to form a seal. The 7S pump comes with the tri-clamp fittings welded on, but will need a power cord attached for the 208 to 240 volt power. The plug for the 7S pump is connected to the pump cord on the controller. Your electrician can remove it there and connect the cord to the pump using the high voltage line drawing on the pump itself. The larger silicone pump hose can be connected from the bottom or dump valve on the fermenter to the inlet port of the pump. And it's a 3/4 inch hose with the March 815 and a 1 inch hose for the March 7S. Connecting to the bottom port is generally the best. It will allow for the most even flow through the grain and will generally yield better wort clarity. If you find that grain plugs the pump, you're probably mixing the mash too vigorously or too near the bottom of the colander, or your crush size is too fine, which will also cause or increase the risk of grain scorching on the element and ruining the flavor of the beer. If the line is frequently plugging due to too much grain entering, it can be connected to a side port on the cone, and the grain that falls through the colander false bottom can be removed from the bottom of the fermenter and just brought manually up to the top of the colander. To minimize plugging due to grain, only connect the recirculation hose to the bottom of the fermenter after grain bed agitation is completed and the bottom cone has been cleared of grain that may have settled there. The long, narrow hose, the 1/2 inch hose, should be connected from the exit or the top port of the pump or to a valve attached to the exit port on the pump, and the other end to the inlet port of the mash colander or the valve attached to the colander if you've set it up that way. The pump cart should be assembled according to the drawing that is included with the pump cart. And the water level sensor, which is included with the barrel and a half of the 7-barrel BIACs, can be hung off the side of the mash colander with the tips in the water in the fermenter and connected to the power controller. When the pump is on auto, if the tips become exposed, the pump will shut off, helping prevent heater or dry fire in a stuck mash. Use a valve, not the level sensor, to control the flow rate. Otherwise, the level sensor will be cycling the pump too frequently. Section 12, Mash Colander. Install the mash colander 90 degrees hose barb to the inside port on the mash colander and attach the short hose 2 to 3 feet to direct the wort back into the top of the mash colander. Slip the hose float over the end of the hose to keep it from sinking down into the mash, and a hose clamp can be used to keep the hose float in place. When recirculating wort out the bottom of the fermenter and into the top of the colander, it is important to throttle, or partially close, the valve on the mash colander so the pump doesn't withdraw wort too quickly. Never throttle on the inlet side of the pump, as this can starve the pump and cause damage to it. If the pump withdraws wort too quickly out the bottom, 3 things can happen. First, it creates a pressure differential which pushes the grain down inside the colander, plugging the false bottom, and which will lead to a stuck mash where the wort cannot flow at all. Second, the wort level in the fermenter surrounding the colander and immersing the heater elements will drop so low that the elements are exposed, which could melt or damage them. And third, the pump will be damaged if it's ran dry. After brewing a few times, you get pretty used to the flow rate that should be desired, so just using the valve will allow you to keep the flow at the level that it's supposed to be. The wort level should stay almost constant throughout the mash period. If it starts to rise in the colander, it means the pump is moving wort too fast, so close the downstream valve further, slowing the flow down. If wort is not passing through the colander at all, the mash might be stuck and need to be stirred up again and the filter bed reformed. The pump can move liquid much faster than is recommended, so the recirculation rate should be throttled back considerably during mash and Vorlauf. Always keep the pump below the fermenter in order to provide sufficient head pressure into the pump, and if the pump starts screeching, turn it off immediately or it could be damaged. The screeching normally means that the supply is not getting into the pump, and it may be caused by grain plugging the pump. More information and tips can be found by searching for stuck mash on the BREWHA website. And that's it for installing the BREWHA BIAC. If you have any additional questions, answers can be found by searching the BREWHA website. And if anything still remains, feel free to send us an email.